Hello again, everyone. We are now going to begin our next session. We have a panel on the topic of things to consider in design when aiming for AM production. We have with us as the moderator, Zach Holcomb, CEO and co-founder of Additive America, Jerry Olesen, manager product care engineering Dishcare at Electrolux AB, Milad Nikokar, I'm sorry if I pronounced that incorrectly, Additive Services technical lead of Facebook, and Jason Enos, founder and CEO of Empire Group. Welcome, everyone.
Thank you.
Thank you. Thank you so much.
Thanks, Andrea.
And I'll hand it over to you. Thanks.
Right on. Right. Are you able to grab Jason for us as well?
Yes.
Sweet. I know you guys are on it. I shouldn't have even questioned. I know you guys are on it.
We'll be here shortly.
For sure. Sounds good. Hi, everyone. My name is Zach Holcomb. Like Andrea said, I'm with Additive America. Super psyched to have a couple folks join us today. We're going to talk about, like she said, things to consider in design when aiming for additive manufacturing production. So we have Milad from Facebook, and Jerry is from a company called Electrolux. Jerry's local to me here in North Carolina. And then we have Jason Enos as well. He's the CEO and founder of Empire Group. So, Jason will hop in here. He's a cool enough guy. He'll just jump right in. So we'll just go ahead and get started. Got a lot of time to chat here and want to fill it really well. So first disclaimer, we're looking for those questions. So hit us up with the Q&A stuff. Anything that you're looking for, get them in there, and be sure you guys are checking on those. Vote up the questions that you want us to answer. Q&A is like my favorite thing in the world. So we'll make sure we get to a lot of that fun stuff. But yeah, I'll kind of go around here and let folks introduce themselves. We'll start with Milad, man. Go ahead, give us the rundown, a little introduction. I know you and I met about a week or so ago here, kind of leading up to this event. But give them the rundown, man.
Yeah, sure, absolutely. Thank you so much, Zach, for brief introduction, and thank you everybody for joining to this panel. I hope we have a very good discussion together. So as Zach mentioned, my name is Milad, and I'm currently with Facebook leading their additive manufacturing efforts in the area of hardware engineering. And just very briefly, I start from University of Louisville and in powder bed technologies, SLM mainly, and then University of Cincinnati Research and Institute and Evonik later on, and right before joining Facebook, I was with EOS for some time, and I have been focused on powder bed technologies my entire career. I jumped back between metals and polymers, but has been mainly SLS and SLM, and currently working about a year that I'm with Facebook, and we are focusing on leveraging some additive manufacturing capabilities to make the next generation hardware for Facebook data centers and some other products and hardware that we have. We can't hear you, Zach. I guess you're muted or something.
If you add too many mute buttons in the system, man, you gotta. Thank you. Hey, Jason, thanks for joining us, man. Welcome on. We're just kind of introducing each other here, just kind of going through real quick. I'll let go ahead, Jerry, give him a little quick background information on yourself, if you don't mind.
Sure. Just to make sure everybody can hear me. Not too many one mute buttons.
You're good.
All right. So first of all, Zach, I want to say thank you for making sure I got involved with this. It's really exciting, as we've talked a lot here since last December when I first met you. Near and dear to my heart in terms of additive manufacturing, the prototype 3D printing for what I do. I am the product care engineer manager here in Kinston for Electrolux. We do manufacture plastic tub dishwashers here in Kinston. And again, I am the product care engineer manager. So my group is responsible for continuous improvement projects within our platform. And one of the things that we did here about a year and a half to almost 2 years ago, we ventured out in about a 3D printer for my group. And we've been doing some work there in terms of trying to go through and do the virtual work in terms of engineering in my CATIA world, doing the stack ups, FEA, DFEMAs, and all that. But really, when it gets down to it, of being able to take actual parts to our production line for our manufacturing teams and also the people put them together on their lines, 3D printing is absolutely critical. And so the first stage, as I said, about a year and a half ago, we bought a desktop printer here in Kinston for my group. Did a lot of good work there, but it's got its limitations, size, the material, and how it's printing. And just by chance, one of my very good friends here in Kinston called me up late last year after Christmas, said, Jerry, says, you got to check what I got into. I just got into 3D printing, and I went out there. Literally, Zach is just 5 minutes up the road from my work and in my home. I went out there and met him, and it started the venture that we are now with Additive America, where what Zach is able to do for me is I'm able to make a change within my CATIA, my virtual world, get it over to him, and he can print it and be back in my place of work within days. And so an example that we have here is that I was working on a continuous improvement for one of our components that is actually in production, made some changes and sent it over to him. He's able to print it. I was able to bring that back into my manufacturing world of a part that is of current design and the new design to take a look at what the differences are in terms of what we're trying to improve upon. And so I was able to bring that into, again, my factory here, get with our quality and our manufacturing team to make sure that the change is going to work. It's what we wanted. And then ultimately what we're able to do is go straight from that 3D print over to production tooling change versus updating a prototype tool. So the turnaround has been extremely quick. And so since we've had that very first example, we've sent a lot of work over to Zach and his team, and they're very quick and responsive to get parts back in, again, back into our world. So obviously what I see is, as far as this is quicker to market for what we need to do within my world.
Right on, right on. Thanks, Jerry. And yeah, we'll get a little bit more into that use case that he kind of brought up there as well here in a sec. Jason Enos, he's with Empire Group company, founded up there in Massachusetts, I believe. And yeah, kind of like a full, well-rounded, they got a little bit of everything type of a spot. So I'll let him kind of explain that in a brief intro here as well. Go ahead, Jason.
Yeah, thanks, Zach. Thanks for having me. Yeah, we own a full service product development company here in the Northeast. It's actually a company that I started, God, it seems like yesterday, but it was actually 20 years ago. It's like 1999. I'm like, it's like crazy. I think there's like a Prince song around that, but it was crazy. I can't believe it's already gone. I can't believe it's gone by this fast. But the thing with us, we embrace the technology like really, really early on. My background, I was a pattern maker, right? And I just loved making things with my hands and all of that. And, back in the day, I really listened to a lot of my mentors, I guess you could say, and said that you really need to embrace 3D printing if you want to, stay in this industry. So taking that advice, moving into starting my own company in 99, I embraced 3D print right from the get-go. So that's what's led us to where we are today. We've had a lot of experience with all different technologies from, FDM, MJF, all the different, major technologies we use. But we are we're a full service product development company. So we use it for multiple reasons, right? Fail fast, things like that, show models, real stuff nowadays, which is amazing. But we're in all different industries. We use it in the medical industry, consumer goods, military, you name it. We do a lot of crazy, unique projects. But what we offer is an end-to-end solution. So we do a lot of the upfront design work, the napkin sketching we actually do, a lot of the ideation straight through to a full service prototype shop, which we do a lot of high-end finish work, mechanisms, prototyping, general fabrication, weldments, you name it. Then we have a full service 3D printing house, which we do everything from, just growing parts for people, growing parts for ourselves, manufacturing, all kinds of stuff. And then CNC machining. We have a full CNC shop where we do a lot of military work, a lot of tight tolerance, high-end stuff. It's really exciting. There's never a boring day. You never know what you're going to work on the next day. I just love it. It's been something that I've been doing my entire life and never knew there was a job for it until I, grew up a little bit more and figured it all out and just have fun every day doing it.
Right on, right on. Yeah, it was kind of like the same way, man. I like people are like, man, when did you find out you wanted to get into 3D printing? I'm like, I guess I didn't really know. I just fell into it. And they're like, well, like, what's like the earliest memory where in life that's something that you remember now that you're like, dang, now I see how that all kind of came full circle. And for me, it's like, I remember being like 7 or so. Yeah. And like, we all did the Lego thing, right? So like, that's like yeah, we all got that. But I remember being like 7. And so like the toddler toys weren't cool anymore. And so I had a screwdriver that I found, and I started taking apart all the toddler toys to like figure out how they work together, and like seeing the backs of like injection molded pieces and stuff. I didn't know that that's what it was called when I was 7, but I used to do that stuff all the time, man. And now I'm like, yeah, imagine that. Now we're all looking at paintings and
I know, it's crazy. Mine started with model cars, right? It's pictures of me when I was 5 years old with an X-Acto knife. Can you imagine doing that nowadays?
Yeah, right.
But yeah, it's crazy. But yeah, that's cool.
It's good stuff. It's good stuff. Yeah, Malad, I mean, Malad was telling me last week, we were chatting, he's kind of been kind of through a lot of the technology. So I know, like, for Jason and myself, you know, Jason's got a lot of the technologies in house. You know, he's running SLA, doing some triple F, running an MJF machine in his own building. So a lot of things kind of tied together all at one time. A lot of my histories, programming legacy 3D systems, SLA machines, a little bit of Union Tech, done some carbon stuff, done a little bit of HP here and there.
Uh-oh.
Did we lose him?
Uh-oh. Lock up.
Oh.
Are you back?
Yeah, I think we're back.
Yeah. Lock up.
A lot of you were kind of chatting a bunch about some stuff that you'd worked through, and basically, you know, it's Jason alluded to it, of failing fast. And it's kind of something that, you know, we all are kind of into. And I think that is, you know, early on as folks get into 3D printing, they want to make sure that every 3D print is successful. But I think once you start learning that failing is like really awesome thing, it kind of changes the whole. Once you lose the self-consciousness of it's kind of the coolest tool in the box. But yeah, go ahead. I know you had a cool one for me on that.
Yes, yeah, absolutely. So I kind of started as I'm not gonna go that back to my childhood, but yeah, we kind of like started all kind of like breaking apart stuff and see how things work, and trying to kind of like cannibalize one to save another kind of like piece, and take gears and stuff like that and put it together. And I continued that to conventional manufacturing. So my background was in industrial production, and I started with CNC and with kind of like casting and molding and all those kind of like conventional manufacturing. And that was about, I guess, 2009, 2010 that I heard about 3D printing, and I started kind of like pursuing that. It's kind of like much cooler and making stuff. So, and ended up in 3D printing. And back to your point that you kind of like about the failing, actually, I work a lot on process development and on R&D material and R&D processes. So it's basically, for us, it was usually 90% failure and about like 10% kind of like success. And when you got the success, it was just kind of like, some of it was kind of like on the edge. You're just kind of like, you're able to make like one part with this new material, and you still had to kind of like work a lot on it. And it's really good. Even as one of our colleagues in EOS used to put it, that kind of like gained a lot of experience and things that didn't work. So whenever we had a new material or a new project, we knew at least things that we kind of like we cannot go, and the dead ends. And that was mainly just sitting out and trying different things with the machine, trying just kind of like different parameters, different materials, different type of like powder particles and things like that. So it's mainly for the R&D world, it's mainly failure. So so you just have to make a lot of mistakes and learn about it. And there is no other way of learning a lot of these. You have to sit by the machine, and you have to just take the time and try over and over again. And sometimes you ended up just kind of like continuing the process until like it's close to midnight, and then you knew like, okay, I'm gonna get it next time. So it just kind of like, it was much easier to sit there and do another round to kind of like come back the next day and start everything all over and kind of like heat up the machine. So yeah, it's like usually in the additive R&D world, it's a lot of kind of like things that doesn't work, and you have to learn from them and kind of like conclude from like 100 things that each of them, like there's something wrong in a certain way with them, to kind of like aggregate all of them and come up with a way that there is possible success.
Yeah, and then it's the way that a lot of those some things that you consider when designing for certain technologies, and then when you switch over to other technologies, sometimes those principles don't directly correlate, but there's like a similar principle that goes along with them. So I think that's one of the cool things when you start to have the experience in kind of more of a multifaceted experience. It kind of helps what you're able to bring together in each individual one when you're just working on that individual technology. But I know, Jason, you could probably even speak to that a little bit. There's some things from SLA that we kind of apply to MJF, and then there's some things that are SLA that we do opposite or MJF, and then there's some things that don't relate it nearly at all. I know the one thing that I love about MJF versus SLA is that there's this whole thing called supports that we don't even exist anymore. Right. So that which is a whole nother thing to consider.
Yeah, for sure. I mean, I'm a fan of all the different technologies. Everyone has its certain application. And what's funny is even some of the technicians, speaking with them, they have their favorites as well, right? I think SLA has always been our favorite for doing the finish work. But the more and more we're using the MJF, we've created so many different techniques. It's actually a little easier to be training the people to be finishing the MJF type stuff. But the SLA is super fast, right? It's just easier to unpack, and I guess that's not the right word to use for SLA, but you know what I mean. It's easier to break it down and get it out on the floor fast, right? So that's still usually our go-to. With us over here, it's all about speed, right? I mean, it's, I guess, the whole industry, right? And it's really getting parts to the floor as fast as humanly possible for these guys to finish and prep and move on to the next thing. So, but yeah, there's a lot of pros and cons, right, of each one of them. I'm a fan of all of them, every single one of them. I'm excited to learn some of the new stuff that's coming. Even, we're geeking out over here right now with the new technology. We're bringing the miniature stuff that I just think it's incredible, because it's a whole area that people to this, it's almost like bringing me back to the start. It's like, we're going to be able to get to an audience where people haven't been able to prototype anything at this scale prior to this, right? So it'll be really cool to show all these guys how they can fail fast creating small stuff. So it's going to be cool. I just don't know if my eyesight's going to be up for it. I'm walking around with a scope everywhere I go, just looking at stuff, right? But
right.
Yeah, it's cool. It's an exciting time right now to be into all of this. It really is. I mean, it's really re-energized myself. It's just, and I know you probably feel the same way, Zach, right? It's like, it's been a minute before, this has probably been I guess 3 years prior to 3 years. I mean, we were making SLAs, try to do the stuff we're trying to make MJF do, right? And that's where I think we've all learned that crash course in DFAM, right? That's the buzzword now, but I don't know what we called it back then, right? It was something different, but making it work.
Yeah.
But when we always took SLAs and knew that, all right, if this was going to do X, Y, and Z, we needed to, thicken up the wall here. We need to do this here, and knew what we were going to get out of it. And that's why, moving into some of this new technology and really, really being able to hone in some of those techniques and making things really, really work at the level that we're at the R&D level, and really get a true test of what the product is going to do is just amazing. Especially when we do a lot of work for inventors and stuff. We're actually able to make the product work and do exactly what it's going to do, and actually last maybe, a lot more times than 1 or 2 times, with an SLA. So, but SLA's come around too, so I don't want to really dog that either. SLA is awesome too, and it's got a lot of new materials coming. So it's just another toolbox, another tool in the toolbox, right? Is how we look at everything.
Absolutely. It's interesting how you design different things for different projects too. Like if you've got, you guys have projects, you guys do a lot of urethane casting. So, you've got part files that you're getting. If you're getting a part file and they've got, draft built into their part file and things like that, because they're really just proving it out in a short run case before they're going to hard tooling, that's fine. It works great for your SLA things. But if you have someone that's designing a part, they're not incorporating draft into their design specs because they're like, we're just going to MJF this part, and then you go and try and do, try and take that thing back the other direction. You can always, we kind of laugh about that as you can MJF. You can MJF a part with or without draft, but you're not going back the other direction, obviously, for obvious reasons. But some of the considerations that you have to take into account when you're doing all that. I know that we've dealt with some of that. not even for going into full production. We've all seen things where, the DFAM, the designing for additive manufacturing case, I think like one of the greatest ones, I think like hands down, the best case of that here recently, it definitely in an HP situation is the frame that Avid put out for like the face shield frame and how it all folds up and it prints in like the space of a nerd rope. I mean, that's amazing. That's what we're talking about. When you start getting in at the first design meeting, this is how we're going to produce it. You're able to really maximize on that curve. So, we're all about staying home and flattening the curve, but when it comes to designing for additive, we do not want to do that.
Exactly.
It's kind of interesting too, is that, to bring it all kind of full circle, Jerry's in a situation at Electrolux. They're a very large company. They're not jumping at, they're not chomping at the bit right now, as a lot of large companies just aren't, to change their manufacturing from largely injection over to additive manufacturing. For a lot of things that they're making, the quantities are so huge that it's not going to make sense that injection molding will continue to be a large portion of their thing. But it's cool and it's interesting to watch companies and their design engineers start the transition kind of at the level where Jerry's at in Electrolux. And, we're trying to produce, he's prototype tooling a lot of his parts, but we're able to kind of micro down on what he's actually focusing on those larger parts. And a lot of those parts that go in a dishwasher don't fit in a lot of our additive machines.
Right.
And that was kind of a use case that we kind of worked through. Jerry, you kind of want to talk about that, kind of how we worked through. Jerry called us up. We went to his plant and he showed us his part and was like, we want to 3D print this. I was like, man, that ain't going to fit. But we ended up figuring out a way. Jerry, you want to tell him about that?
Yeah, so appreciate it, Zach. And then ultimately, I want to back up just for a moment what you said all on as far as the technology. Obviously, where I am, we are not 3D printers, don't pretend to be. But as I said, I went and bought a desktop printer about 1.5 years ago, and it's with a carbon filament, so it lays it down in layers, right? And so the thing that we're able to do is for very simple parts, we're able to get them off that bed, get them into our hands from an R&D perspective, test to a certain degree within the dishwasher system, then ultimately get them out to the manufacturing folks for initial and cursory glance at form, fit, feel, and finish, and things like that. Both the technology that I have here in my factory with what I bought, obviously, as you mentioned early on, Zach, it builds it in layers. And for some cases where it's a simple part, it's a good thing to be able to have it in my hand as a talking point, a little bit of testing. But when it gets down to the intricate details, that's where I ran into some issues. And when Zach and I first met, I started talking about that. Like I said, he came over to my factory with his team, and I was able to have a production part in my hand and give an idea, this is what I want to do in terms of my continuous improvements. And where I was wanting to improve it was, in fact, a very detail-oriented place where my printer would not work. So talking with Zach and look at it, threw the part on the table, and he says, just that. He says, man, I can't build that whole thing, but let's see what you're really trying to dive into. So what I was able to do was sit down with him probably within 20, 30 minutes and then say, basically, here's what I'm looking for. And the thing that's critical for me is what I was trying to do is want to understand how I was going to work on the line with my design improvements, but also in the end, when this thing gets fully assembled, how is it going to react accordingly when I put all my parts into place, so to speak, right? And so what I was able to do is, in talking with Zach, is again go over with what I wanted to make sure we spent the time on focus on, get the part where we could print it, but also be able to get it into my hands and look at it where we snap all the parts together, put everything together, look at it from manufacturing assembly perspective, but also then do a quick check on the performance of what I was wanting to change. And so what we're able to do is I took a design that was the current design in production, knowing what we're trying to solve, and then produced a couple different variations of what my proposed change was. So I was able to put that through the manufacturing world and then go through my labs and go through the performance testing. And so I was able to do that in a rapid manner. So I was able to get Zach on board, get it through the printer, and the results were such that it actually exceeded my expectations of what the outcome was. And I was able to basically skip my prototype tooling stage update and go straight into production. So therefore, we saved weeks of what we normally would have done in the past. And so where I see this moving forward is obviously with that case study in mind, I've already got my engineers reaching out to Zach for various things of trying to understand what his capability is and ultimately what we can test to. And so from my perspective, Zach, in literally my backyard, has expanded the 3D printing world within my realm of where I am. And it's just tremendous what I think that possibilities are in moving forward. It's an exciting thing for sure.
That's great.
Yeah, it's really cool. We had when we took the part, we had ran like the first run of them, and we cut the pieces, and thin plastic. When you get it really hot and it's got no ridges or any frames around it, it just wants to warp and twist. So we actually printed the first run of parts for Jerry, and one side of it came out great, and the other side was all warped and twisted. It was 100% my fault. Like I was like, don't fast cool that build, and I was like, we're gonna fast cool it. We're gonna hook Jerry up Monday morning. He's gonna come in. He's gonna be psyched. And dude, we pulled those parts out. They were twisted. So anyway, well, kind of to pull it all back here and really, I'll touch on the title of the whole thing. We had to go back and look at it, and we actually found that if we trimmed the part a little bit more and brought back some of those flanges that we didn't actually need. I think Jared was standing there. I literally had my HP part in a Sharpie, and I was like, can I cut it right here? Is that cool? And he's like, yes. So, kind of some of the taking into account of what technology you're using and the proficiencies and the deficiencies of it, and then working that all together is kind of an interesting thing. I mean, we've all worked with companies that are at different phases of the adoption or of the experimentation. So, it all takes form in different ways and manifests, but it's kind of interesting to see how a company like Electrolux can kind of work in and kind of do some of that stuff. But it was really cool.
And one thing to that, Zach, if I may, just one thing once we get beyond this COVID-19, one of the things I want to do is I still want to bring Zach back into the factory, because I've always thought of rapid prototype 3D printing as far as R&D world, basically, right? And so I've done that in the past where in my previous life, I used to have the SLA where basically warping your hand from the heat and crack and, whatever. But now with this kind of technology that Zach is able to bring in and understand, I want to bring him in and see what we can do from a manufacturing perspective of fixtures and go, no-go gauges, things like that. So I think it's just an exciting time just to think about what the technologies that continuously evolves and improves and takes leaps and bounds of innovation, how we can then put that into the entire world of manufacturing.
Absolutely. I'm going to loop kind of back through here. I'm going to start kind of rolling down some of the Q&A list here. We got about 15 minutes left. So if you got any questions, you thought of anything here, go ahead and plug those questions in over there and vote up the ones that you really like. If you got some really hard ones, vote those ones up. We always like that. I'm going to just go right off the top and work my log right back into this panel. Got 28 votes on this one, big man. They want to know, what does Facebook actually produce and why would they need additive manufacturing?
So yes, this is a most frequently asked when they're kind of like in a conference and things like that. It's a little bit unusual for a software company to have invested into some of these manufacturing methods and things like that. But not many people know that since I guess 2011, Facebook started building and operating its own data centers. So, and part of the reason being that with the demand that we had and with the user growth that we had over our platforms, it just things off the shelf of the market was not could not keep up with our demand. So we started making our own data centers and operating them. And you can imagine a lot of the different pieces and hardwares are going into a data centers. And with the growth of the demand and with basically you have more and more like high quality videos and people just keep kind of like, for example, you take a platform like Instagram, everybody just keep uploading their content and nobody ever takes anything off, obviously. So these high quality pictures and videos and all that, there is kind of like this increased demand. And if we look into our capacity demand charts, it's always going up at the exponential rate. It's never even kind of like have a break in it. So with that said, obviously our hardware engineers try to make things more efficient because the space and the floor space is limited in all the data centers. So the only way to keep up with the demand is to really increase the efficiency. And they started packing more and more power into smaller and smaller footprint. And one of the things that we have ran into, for example, is how to keep them cool. because we have to have those chips are operating at a certain temperature, and if that goes any higher than that, it's just computer just overheating and having all those issues. So that is just one piece of the additive usage that we have in Facebook. And other pieces are our other hardwares that are more geared toward the consumer goods market. For example, we have the virtual reality headsets and handsets that are under the brand of Oculus. So they are fully designed and prototyped and tested in-house and just shipped out for manufacturing in a mass manufacturing plant. And we also have the other business called Facebook Connectivity, which they are basically aiming to develop methods to provide internet access to especially to underprivileged areas of the world. So they are focusing at different layers of how that system works. So they started with satellites and their high altitude planes and ground grids and things like that. And all those pieces, they are fully designed and developed internal Facebook. So we don't do a lot of manufacturing, but and manufacturing actually on site. So all the manufacturing are being we have partners that we are working with, and they are doing the full manufacturing, but all the design and development and prototyping is being done on house. And now that we are looking into additive for some of these solutions, because for example, some of those cooling systems, heat sinks, cold plates, things like that, we are taking advantage of all the geometrical complexity that additive offers. And now we are charged with trying to find a way to scale that up. And when I'm talking about scale up, we are not even talking millions. We are talking like something like 100,000 parts a year, but still something like that for a DMLS platform for metal printing is still challenging, and there are not any places out there that you can just take your part and just they have like a fleet of 100 or 200 machines sitting there and waiting to just mass produce this part. And that basically has been some of the issues that we had, kind of like we are facing currently. And I've seen a lot of the engineers that they are coming up with the best prototypes. They are just more coolest design and all that. But then when we start talking about how many parts they want, and remember, these engineers, they are the people who used to like work with injection molding, with like CNC casting. So they are kind of like more familiar with this high volume and low cost production. And then imagine a discussion having with such a person that already always dealt in like tens of thousands and maybe just the daily throughput, not even annual. Now we are talking about I'll make this prototype on the DMLS, but it's probably gonna take like 60 hours to make one, and it's gonna cost like so many dollars. So it is and has been usually kind of like hunting down additive, a lot of discussion about a higher scale production, and it's not easy. I totally understand that it's not easy. So for example, you can make some prototypes and it might come out great out of your machine, but then if you start making like trying to fit 50 of those parts and trying to stack those parts in layers, in like 10 layers, then it becomes really, really tricky. And it's just a simple problem. It's error propagation. So, for example, in your MJF process, you might have a little bit of warpage because you don't have a uniform thermal profile around your build plate. And it might be good when you make like one or two parts, but when you start stacking 10 of these parts on top of each other, then that's kind of like a little bit of error is starting kind of like to add up and snowball. And next thing you know, you end up with a failed build. And that failed build, it's a lot of material, a lot of time, and a lot of parts potentially. So some of those basically things that that are those considerations in the design especially are very important. And here at Facebook, we are kind of like ended up having this process that two-stage DFAM. So the first DFAM is your general kind of like design for additive manufacturing. You kind of like make sure everything is kind of like looking great, your overhangs, your thin walls, things like that. And then in the next stage, you have to kind of like start looking at, okay, what are some of those features that you might get away with like prototyping it, but might not necessarily come out great in a manufacturing, in a fully populated build platform. And I had this conversation with some of the OEMs that they say like, okay, we can make 1/10 of a millimeter. It's doable. But 1/4 millimeter thin wall is really where we feel comfortable we can get repeatable design, repeatable results.
Yeah, that's
so a lot of those things that kind of like led us down the path to kind of like having this two-stage DFAM and just making sure all the designs are good for scale-up production as well.
right on.
Sorry, it was a long answer to a short question.
Oh, you're good. You're good. I got this next one coming up, so we're kind of working there anyway. We got this one here, Jason. This is probably right up your alley here. You know, it's a loaded question, but it's like the realistic volume sweet spot for AM applications, right? You know, we've all been there.
I knew you were going to ask me that. I think this is a tough one to answer, really, because it's definitely loaded because it really depends on the product and what you're actually doing. You know, for me, just my experience, right? Just my day-to-day and the type of projects we're doing, my sweet spot thus far has probably been around 1,000. I don't know if you agree with that, but I say we can usually get the pricing right for that type of quantity. Beyond that, we struggle. And that, again, it really depends on the part. It's a case-by-case deal. You know, there's been some stuff that's really surprised me that I'm like, wow, I wouldn't do this any other way than this. And what I think it really comes down to is just the whole thought process from the get-go, right? Really looking at it from the design side of it, where you can go, all right, if I combine these parts and I do this and I do that, I can create this whole assembly in a non-traditional manner and get the pricing right. It's all about the pricing at the end of the day, what makes sense. And there's always an intersection point of that pricing that you need to figure out. It's like, all right, you know, I mean, I think that's the key. The other part of it is how you actually using the tool too, right? Depends on the quantities. You know, I'm a big fan of, you know, using this as a tool. It's just another, it's like another stopgap measure before tooling, right? But it's just a little bit further on. It allows you to get out to the consumer and really make a decision around the product to really protect that investment of the tooling, right? So you really got to challenge your way of thinking when you get into it. No, is that a good enough answer?
No, I agree with you. I totally agree. I think like more so in like these are like the basics, but you know, it's like saying this is common sense, but you know, my brother always argue with me. There's no such thing. It's if you can start and you talk about pricing, everything always comes down to cost. Compete with injection molding on the pound cost of plastic, which is not. But when I can start designing and putting in 7 of those injection molded parts plus that person that sits there and assembles those 7 parts, oh, okay, well now we're in the same ballpark. If I can take that 32-piece CNC assembly that's got set screws and Loctite, and that guy that's like, did you use the red one or did you use the blue one? I don't know, boss. Was it before lunch or after lunch? There's always that mark. I think that's where additive really lends its hand, is it allows us to remove a lot of the human factor from the manufacturing process by combining those assemblies. You know, I like to think of it as like this whole additive thing. It's like it's the internet for manufacturing. And people laugh and joke. And they're like, oh, the machines are going to steal jobs. I'm like, no, we used to have people that did this and plugged different phone, like you called and they were like, hi. And you're like, yeah, grandma, please. And they're like, oh, Grandma Green? Yeah. And they plugged it in. We were like, don't get rid of that, because what are we going to do with all those operators? They're not going to find jobs. Like, we find other things to do. And I think that's when you find technologies that come along and they start really pushing and they start knocking on the door. When they finally walk through the door is when they start combining a lot of things like that. So for this, I think in additive, it's combining assemblies, it's combining steps and processes into fewer parts. And that's how we can add to the value. It's a value add more than a how much is that part. I always get asked. I get asked all the time, like, what's your part? What's your plastic cost? And I'm like, I don't like having a good answer for you. I'm like, how do you put those 7 pieces together and not have to pay the guy to put them together? Ooh.
Yeah.
So
right. I mean, look what it's done. I mean, but then you look at what it's done just for the situation we're in right now in the world, right? How much it's been able to come online and really make a huge difference. And we're actually, you know this, we're getting creative with quantities, right? We're getting creative. Just look at what Avid did with that design. You know, it's just getting creative of the technology and understanding the technology and how to push the boundaries to actually get to the volume you need. So it's exciting times, and there's more to be had, and it's going to change by the minute, especially with everything that's going on.
Yep, absolutely. It's a great instance of distributed manufacturing as well. And I mean, and we talked about the volumes. You know, we don't know about the, what volumes. I don't know about how many face shields other people are printing, but I've printed a large number of them just here at our place. So, it's distributed manufacturing, and its quantity is much larger than we would have ever thought possible. So I'm getting messages here blowing up that we're getting asked some difficult questions. So we're going to get to the difficult ones. Cool. I'm just going to shoot random here. We're going to go really quick. So they're going to let us go 5 minutes over. So these are going to be 30-second limit answers, and then we're going to cool. All right, here we go. First one. Do you ever begin a design project with an open-ended production process, or do you always have an AM process in mind?
Oh, for me, always open-ended. Always open-ended. We look at we look out for our client, right? In their best interest. So we look at all solutions, but at the end of the day, it's all about the client and what their expectations are and helping them the best we can.
Absolutely.
Yeah, if I may add really quick here, Zach. So yes, that would be the best way to approach it, open-ended, and to put kind of like as low restriction as possible on engineers, so they can kind of like really execute and take advantage of design freedom. And then you can go back and say, okay, that angle, I need that to be a little bit changed because of the process. So I got always the best result with open-ended.
Yep.
Right on. I'll just jump in for me on, we're kind of a little bit of both open-ended, but we have one technology in the house. So a lot of times we find ourselves actually telling people, I'm not your best guy. Call Jason because he does vacuum forming parts and he'll help you out with that. But I'm more so specific into what I'm doing. Again, contract manufacturer, focusing on a particular technology at this point, largely because of a prosthetics work case that is designed specifically for MJF and MJF only. So a little throw that one in there. I like this one too. What is the best practice for documenting 3D printing process workflow to maximize repeatability of part performance?
We are knee deep in that right now. We are, we're right now we're utilizing all this time to train and to bring in new software and to really get us to the next level. I mean, our company, we're really trying to grow, and we're really looking at our operations and doing exactly this. There's a lot to be done. Do I have the exact answer? No. But I can tell you some of the stuff we're doing. I mean, we're getting into lean manufacturing. We're using Agile, Scrum, a bunch of different techniques and technologies to help us get to that point. The biggest thing that we use currently, we do a lot of QCing. I mean, that's really the only way for us to really document the performance of a machine and what it's doing and repeatability and all that stuff. A lot of the new technology that's coming out, though, has some fixes for that, but there's so much out there right now. There really is. It really all depends on your operation and what you're trying to do. And
I would say kind of like, because I worked in the additive manufacturing facility, kind of like GMP medical thing. So there was like everybody was big on documentation, and that was a very good practice for me to keep a logbook of how you kind of like produce that. So because when you go through design iteration or you start changing and tweaking your process parameter along the way, it's really easy. You find the worst case is that you have a winning combination, you have a part that is made and is beautiful in your hand, but you really don't know how you made it. Was it like, I don't know, 150 or 155? Which one? So if you have a good logbook, you can kind of like keep track of that. And if you kind of like you have to keep account of multiple different angles, right? So you have one surface fully optimized, but then you realize, oh man, I'm really surface. So if you have a good logbook of how many designs and what parameters you ran, you can really go back and see, okay, where things start going bad. But it's very time consuming. That's the drawback of having a logbook, but it's very beneficial at the same time.
Yep.
Absolutely. We kind of do the same thing here out of America. So, and all things in short is we're a startup and we don't have super deep pockets because we're paying for it all ourselves. So eventually we'll be doing, oh man, Amdir is going to love this. He's going to tie it all back together. What we do internally, we use a lot of Google Sheets, Google Forms, Google Docs. We enter in, we have job traveler forms. We enter all our jobs in through there to track everything along there. It allows our salespeople to track where their parts are coming along the process so they can update their clientele as well. It's pretty cool because when we put in a job into our job tracker, and anyone can do it from anywhere within the company, which is cool. It comes in and it actually comes in with like a JPEG or a PNG of the part with dimensions on it. It prints and then it automatically prints out on our printer a full job traveler form with several sheets for doing dimensional accuracy, things like that, QC checks and all that fun stuff. So anyway, when we get big one of these days, we'll utilize Link 3D for all of that. But for now, it's Google Docs. And with that, there you go. Back to Amdir.
Thank you guys so much for joining today.
Thank you.
Thank you.
We will now be going into our virtual networking sessions. If you guys want to stick around and talk to some attendees that have any more questions, that'd be great. Thank you so much, everyone.
See you at 5:02.
Thanks, everybody.
Thank you.
Thank you.
Thank you. Thanks for having us. Thank you.